Welcome to the University of Mathematics, and today we are going to look at sets. What is a set? A set is a collection of well-defined objects. Saying well-defined, I mean a distinct object being put together to form what we call a set. So, for example, if I have a set A containing objects like 1, 2, 3, 4, up to 5, this is an example of a set. Also, another example is B, say A, B, C, D, E, F. This is also a set. Alright, so basically, there should be a collection of well-defined objects. Another example I can say is that, let's say my set S is equal to car, Michael, monkey, a bull. This is also a set. But what is the difference between these three examples? For example 1, we listed some numbers from 1 up to 5. For B, A up to F. And for S, we listed some random objects. So, what is making or causing the difference in S? We could see in A that the objects look alike. In set B2, the objects look alike. Now in set S, we listed some random items, and we are saying that is also a set. The explanation is a set does not necessarily need to be like objects only. They can also be unlike objects being put together to form a set. And that is the reason why set S, or my example 3, also qualifies to be called a set. Okay. Fast forward, let's look at methods of representing a set. The first method we are going to look at is the tabular form. Let's say you have a finite set. By finite set, I mean a set with all 8 elements known. If you want to write a set A in a tabular form, it is simply listing all the members belonging to A. And so, for instance, in the previous example, we listed A to be 1, 2, 3, 4, 5. This is a tabular representation of a set. Our example B was also A, B, C, D, E, F. This is the tabular form of representing a set. Now, elements 1, 2, 3, 4, 5, I mean item 1, 2, 3, 4, 5 in set A are called the elements of A. Also, in set B, the items A, B, C, D, E, F are called elements of B. So the elements of a set are basically the items being put together to form that particular set. The next method we are going to look at, which we'll be using most often, is the set builder notation. Now, the set builder notation is not usual like the tabular form. You could recall that in the tabular form, we write every member of the set directly. So let's say the set builder notation for A is given as X, such that we write the conditions for X. Okay, so this is the form of representing a set in a set builder notation. So you write X and then you put some conditions on X. For example, A is equal to 2x, such that X is a natural number. So this is what A actually contains, but these are the conditions for choosing the elements of A. So X is a natural number, alright, but whichever X we choose from the natural number, we multiply it by 2. So if we try to list the members of A, this is what we are going to get. 2, 4, 6, 8, 9. And it continues like that. So this is A. Another example, let's say we have a set S equal to X, such that X is greater than or equal to 0 and less than or equal to 10. If we want to list the members of S, this is the condition, and this means that X is a number between 0 and 10 inclusive. So the set S in the tabular form will be 0. 0 because we are saying X is greater than or equal to 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Good. This is the tabular form of this set. However, in some situations, we can squeeze out some numbers instead of writing everything. So we can start from 0, 1, 2. Now, from 3 going, we can do ellipses and we write 10. These 3 dots here is called ellipsis, and what it tells the reader is that this set is incomplete. There are more members of the set within this range, and so the person should list them. So all you do is you look at the pattern. We were from 0, we went to 1, we went to 2. So carefully you can guess the next number, and it ends at 10. So these two sets are similarly the same. All right, so that is it. Now let's look at some types of sets. Types of sets. First, we have finite sets. And a finite set is a set in which all its elements are known. Also, the elements are countable. So any set that you know all the elements and you can count them, that set is a finite set. For example, a set like x such that x is greater than or equal to 0 and the same time greater than or equal to 10. For this example, we know that x starts from 0 and ends at 10. So we know all the elements in that particular set. Another example could be a set containing A, B, C, D. This is also a finite set because we know all the members in that particular set. Let's say you have a set S equal to 0, 1, 2 up to 5,000. Do you say this set is finite? The correct answer is yes, because we know the last element in the set and we know the first element as well. So by careful observation, we can count all the elements in this set. So in this case, we say that this set is finite. So in any set which you know the first element and the last element, that particular set is finite. Otherwise, it is not. The next one we are going to look at is infinite sets. With infinite sets, this is a set for which all the elements are not known. And an example is the set of integers. You know, integers are positive and negative whole numbers. You cannot list all of them. And so we say that this set is infinite. The set of real numbers, you cannot list all of them. The set of complex numbers, you cannot list all of them. There are many more. And a set like A equal to 10, 20, 30, ellipses. We don't know what these guys are, and so the set A is infinite. Good. The next thing we are going to look at is a singleton set. What is a singleton set? A singleton set is a set which has only one element. So if I take, for example, a set P to be equal to 1, This is a singleton set. Another one, a set B to be equal to 0 is a singleton set. Note, do not say because B contains only 0, it is an empty set. No. 0 is a number, and so B contains 0 as its only element. The next type of set we are going to have a look at is a pair set. Unlike singleton set, a pair set has two elements. For instance, if I take my set M to be equal to AB, it contains only two elements, and so this is a pair set. If I take my set Z to be equal to 5 and 15, this is a pair set. The fifth example we are going to look at is empty sets. What is an empty set? An empty set is a set with no element. For instance, A equal to 5 is an empty set. B equal to this, just curly bracket, is an empty set. Now note, the set containing this is not an empty set. Rather, this is a singleton set containing phi as its only element. This looks confusing. This set here contains the empty set as its element, yet we are saying the set is not empty. And of course, that is true. Think of this as a folder. Let's say on my laptop, I create a folder A, which contains nothing. And I create another folder B. However, within that folder B, I create another empty folder called C. Of course, folder C is empty, but it is within folder B. And so folder B contains an empty folder. Okay, so folder B is not empty, but folder A is empty and folder C is empty. So this set here, you see, is not an empty set. On this note, if you solve any question and the answer gives you, or you have an empty set as your solution, let's say you solve for a set S and the set S has no element or is an empty set. In other words, we say a null set. If you want to write, you write either S equal to phi or S equal to just curly brackets containing nothing. And this is not equal to this. Please take notes. Take note of this. It mostly confuses students. Okay. Now, the next example, we look at sets of sets. Funny enough, I can form a set A which contains some other sets. Clearly, I can see that the set A contains other sets. So this is what we call set of sets. So basically, a set of sets is a set containing other sets as its elements.